So today we're going to doing the last notes for trimester 1. We're talking about solving logarithmic equations and exponential equations. So solving without a calculator, we're going to use what we know already. So we know exponential form. So I'm going to start this first one by dividing by 48. So we'll end up with our 1/4 to the x over 2 equals 1 over 16. So again, I want to rewrite this 1 over 16 as something of 1 to the 4th. So 1 to the 4th of x over 2 equals 16 is 4 squared. So this is 1 over 4 squared, because 1 squared is 1, 4 squared is 16. This works out. So now these exponents need to be the same. So we have x over 2 equals 2, and x equals 4. This other one, it's written as one solid log. There's not a bunch of them combined together. So I can do my loop. Do 2 to the 3rd equals x plus 1. And then we're going to solve this. So 2 to the 3rd is 8 equals x plus 1. Subtract 1. And x will be 7. So a challenge here. Did you know our logarithm rule here of log of AB equaling log of A plus log of B doesn't always work? So pause this video and try and think of an example where the product, so A times B is 100, but the rule isn't true. Okay. So an example, there's lots of them, but you could have log of -10 and log of -10. So A and B are both -10. Multiply it together, they'd be positive 100. But you can't take the log of a negative number. That's an error. It's not possible. So this won't work. Okay, so why do we care? Why is it a rule? We care because you can sometimes gain or lose answers to questions. So we're going to solve the same problem 2 ways. First, we're going to apply our rule and bring down this exponent. So you have 2 log base 3 of x equals 4. So then divide by 2, we get 2. Now we can rewrite. You get 3 squared equals x equals 9. Okay, do one the other way. We're going to just start by rewriting it first. You get 3 to the 4th equals x squared. 81 equals x squared. Take the square root, and x equals positive or negative 9. This one is the right answer. So doing this way, we lost that negative 9 answer. It disappeared when we brought that 2 in front. So you have to be careful. So here's another image of what this looks like. So if we graph this, this is what it looks like. We get both sides. The reason being, when you plug in a negative number here, it squares it and makes it positive. So you're still getting these because those values become positive before you take the log of them. Here, you're taking the log before you have anything to square it with, so you have negative logarithms, and that doesn't work. So don't avoid these rules, but if you can easily solve it without using them, do that. And then when you finish solving the logarithm function, make sure you check your answer to make sure that it worked and you didn't add a solution, you didn't lose a solution, all that kind of stuff. So decide, what do you think happens with this? So we have log of x squared equals 1,000. We switch that to 2. Log of x equals 1,000. Do you think we lost a solution, nothing changed, or we added an extra solution? This one here, we lost a solution because originally with an x squared, I can do a positive number or a negative number, and it's still taking the log of a positive number. But when I come over here, I can only plug in positive numbers. So I lost that negative option. Same question for this one. This one is you gained an extra solution because you have a positive here, but when you multiply them together, now you have an x squared. So now I can plug in positive numbers or negative numbers, so I added on this negative number right there. Last one. This one is no change, so I can plug in positives. I can still only plug in positives. I can't plug in negatives for this one. Okay, so some more complicated problems. Now we have this one. And note here, before you can do our like switch to an exponential and solve that way, you have to have a single logarithm. So even though we just talked about it doesn't always work when you use the logarithm rules, you need to still use them. Just check your answers. So I'm going to write this as log of x minus log of x plus 4 to the 1/2 equals 1. And then you can combine this into one log. So we'll have log of x over x plus 4 to the 1/2 equals 1. Now it's all one logarithm. You can rewrite it. There's no base, so it's going to be 10 to the 1 equals x over x plus 4 to the 1/2. Now you're just going to keep solving like you normally do. We'll make this a little smaller so there's more space. So I'm going to multiply both sides and do 10 times x plus 4 to the 1/2 equals x. At this point, I'm going to get rid of that square root. So I'm going to multiply everything by 2. Here we'll do it, square everything by 2. And then make sure when you're doing this that you distribute that square to everything. So we get 100 times x plus 4 equals x squared. So you'll have 0 equals x squared minus 100x minus 400. Bring it all to one side. You can try and factor this, but it's not going to work. So we have to use a quadratic formula. So I'm going to make this a little smaller again. So I have room for the quadratic formula. So we want to have x equals negative b, so positive 100, plus or minus square root of b squared, so 100 squared, minus 4 times 1 times negative 400, all over 2a. So just 2 for this one. And then you want to simplify this. I just typed this into a calculator at this point. You'll get 103.85 or negative 3.85. So you want to check at this point which of these work. So here, if I look at this one, it's positive, nothing weird about that. But look at this one, it's negative, so then I need to check if I plug it in, does that work? Or does it make my log negative? So I plug it into here and I add 4 to it, well that's still fine because 4 minus 3 something is still positive. So that one's fine. But if I check here, that's plugging in a negative number, that's not possible. So this doesn't work. And this would be your only solution here. Okay. So next one, we have e to the 2x minus e to the x minus 6 equals 0. Looking at this, try and decide if this looks like something we've ever solved before. Okay, so if you're looking at this, it should look similar to things we factored. So we have a 2x and an x. So you can rewrite this and say over here, x is going to equal e to the x, and just keep that in mind. So I can rewrite this as x squared minus x minus 6 equals 0, and now you can factor like you normally would. So you'll get x minus 3, x plus 2 equals 0. And now at this point, make sure you plug your e to the x back in. So we'll get e to the x minus 3 and e to the x plus 2. You also don't have to switch it to x's. You can just factor like as it is if you want to. Okay, so now I have two things to solve. So we get e to the x equals 3 for one of them, and e to the x equals negative 2 for the next one. So if you rewrite this as a logarithm, we'll get the ln of 3 equals x. That one's positive, so we're good. Then here, rewrite this, we have ln of negative 2 equals x. You can't take the ln of a negative number. That's not possible, so this one doesn't work. Okay, we have two more examples. So looking at this, we have e to the x minus e to the negative x equals 5, over 2 equals 5. So we need to manipulate this to get some sort of e to the 2x like we had before so we can factor it. So I'm going to start by multiplying by the 2. So e to the x minus e to the negative x equals 10. Bring that 10 over. And then the trick here, that's a little bit odd, is I'm going to multiply everything by e to the x, because that will give me an e to the 2x as the first term, because you add x plus x. So we'll get e to the 2x. The middle term is e to the x minus 10, e to the x equals 0. So this one right here is going to become e to the 0 because x minus x is 0. And then e to the 0 is just 1 because anything to 0 is just 1. So we end up getting e to the 2x minus 10 e to the x minus 1 equals 0. This one you can't factor, so you have to do the quadratic formula. So we have e to the x equals our negative b, so 10 plus or minus square root of 100 minus 4 times 1 times negative 1 all over 2. So just type this into a calculator. You'll get e to the x equals negative 0.099, and e to the x equals 10.099. So rewrite them. You'll have ln of negative 0.099 equals x. That's not possible. Then this one, you'll have ln of 10.099 equals x. That is possible. Since we already have decimals, just type that in, and you'll end up getting x equals 2.31. Something like that. All right, next one. Here, there's more than one way to do this. I'm going to start by multiplying by the denominator. So we'll get 400 equals 150 times 1 plus 95 e to the negative 0.6x. At this point, you could distribute the 150 in, or you can divide both sides by 150. It doesn't really matter, they'll work out the same. I divided both sides by 150 just to make the numbers a little smaller, but then you end up with decimals. So again, it doesn't really matter which way you do it. Then you can subtract 1. Divide by 95. And now I'm down to just one e, or one exponent, so I can rewrite it. So until you are at one exponent or one logarithm, you can't rewrite your equation. So this then becomes the ln, I'm going to move this over a touch, the ln of 0.0175 equals negative 0.6x. So divide by 0.6, you end up getting x equals ln of 0.0175 divided by negative 0.6. Type that into the calculator, and x will give you 6.74. If I can write what I'm saying. And that would be your answer. And then here's your homework. And let me know if you have questions.